Let's talk about glass, something we use every day, often without a second thought. From the water we drink to the windows that let in sunlight, glass is everywhere in our lives. It's in our kitchens, our cars, and even in the screens we stare at. But have you ever wondered what happens to all that glass once we're done with it? Most of us simply toss it away, assuming it will be recycled or disappear. But the reality is, we rarely think about glass after it leaves our hands. The truth is, most glass ends up in landfills, where it can sit for thousands of years without breaking down. Unlike organic waste, glass doesn't decompose or return to the earth. But there's hope. Innovators and engineers have discovered a remarkable way to give discarded glass a brand new purpose. Enter foam glass, a material that's changing the way we think about recycling. The process starts by collecting used glass bottles and crushing them into a fine, sand-like powder. This is the first step in transforming waste into something extraordinary. Next, this powder is heated in special kilns at extremely high temperatures. As it bakes, a chemical reaction causes the glass to expand and puff up, almost like bread rising in an oven. The result is a lightweight, rigid block filled with millions of tiny air bubbles. These bubbles are the secret to foam glass's unique properties. Thanks to its cellular structure, foam glass is an incredible insulator. It's fireproof, waterproof, and even resists pests and mold, making it ideal for construction and industry. Yet, despite these innovations, millions of tons of glass are still thrown away every year. These mountains of waste keep growing, taking up space and harming the environment. By turning this glass waste into foam glass, we're not just cleaning up our planet, we're also creating a valuable resource that can be used again and again. These finished foam glass blocks are shipped out to become part of new buildings, roads, and infrastructure, proving that waste can be transformed into something essential. This is the heart of the circular economy, where materials are reused, recycled, and given new life, instead of being thrown away. In this video, we'll follow the fascinating journey of glass as it's collected, processed, and reborn as a high-tech building material. You'll see how every step, from collection to crushing, from baking to shaping, turns ordinary waste into something extraordinary. It's a story of smart engineering, creative problem-solving, and a commitment to sustainability that benefits us all. Turning trash into treasure, one glass bottle at a time, and showing how innovation can make a real difference. So, grab your hard hat and join us as we dive into the magic of foam glass, a journey where waste becomes wonder. The journey of foam glass begins with mountains of discarded glass, primarily industrial waste collected from factories, demolition sites, and large-scale construction projects. These sources generate vast quantities of glass that would otherwise end up in landfills, but here, they're given a second life. Unlike the mixed and often dirty glass from household recycling bins, this industrial glass is much cleaner and more consistent in quality. It's often free from food residues and labels, making it ideal for high-value recycling processes. Every day, truckloads of this glass waste arrive at specialized recycling plants. Here, the real transformation begins, starting with the crucial step of sorting. The incoming glass is a chaotic mix, different colors, shapes, and a surprising amount of contaminants. You'll find everything from metal scraps and plastic fragments to bits of paper, wood, and even rocks mixed in. The first step is to remove the obvious, oversized trash. Workers and machines work side by side, picking out large non-glass items that could damage equipment or compromise the recycling process. Next, the glass travels along conveyor belts into high-speed optical sorting machines. These advanced scanners use sensors and cameras to identify glass by color and composition, separating it from anything that doesn't belong. In a split second, powerful air jets blast away unwanted bits, plastic, metal, or ceramics, leaving only the purest glass behind. This process happens in milliseconds, ensuring efficiency at massive scales. Even after all this high-tech sorting, skilled workers perform a final inspection. Their trained eyes catch tiny contaminants that machines might miss, ensuring the highest possible purity. Purity is absolutely crucial at this stage. Even a small amount of contamination, like a stray piece of metal or plastic, can ruin an entire batch of foam glass, making this step vital for quality control. This is painstaking, detailed work that demands focus and precision, but it's the foundation for producing high-quality foam glass. that meets strict industry standards. Only the cleanest, most thoroughly sorted glass is allowed to move forward to the next stage, ready to be transformed into something entirely new. Next, the sorted glass is still in sharp, uneven chunks, not ready for foaming yet. These jagged pieces are dangerous to handle and need to be processed further to achieve the desired consistency. It's fed into a hammer mill, where steel hammers smash it into smaller pieces. This initial crushing stage is crucial for breaking down the glass into more manageable fragments. Then, a ball mill grinds it down to a fine, flour-like powder. The ball mill uses rotating cylinders filled with steel balls to pulverize the glass, ensuring a uniform particle size. The particle size must be just right for even melting and stable foam. Technicians meticulously check the ground glass to ensure it meets the precise specifications required for the next steps. After grinding, the powder, called cullet, goes through more purification. This step removes any remaining impurities that could affect the quality of the final product. Magnets pull out any stray metal and sensors scan for non-glass particles. These advanced technologies ensure that the cullet is as pure as possible. Purity here reaches up to 99.9%. Even tiny impurities can cause big problems later. The high level of purity is essential for producing high-quality foam glass. The clean powder is stored in silos, sorted by color and particle size for custom blends. This organization allows for precise control over the final product's characteristics. This transformation, from shards to refined powder, is key to making quality foam glass. The journey from raw, broken glass to a fine, purified powder is a testament to the meticulous process involved. The dirty, noisy work of grinding is done. Workers clean up the area, preparing for the next batch of glass to be processed. Now, the science of creation begins. Scientists and engineers take over, ready to transform the purified glass powder into innovative new materials. The glass is ready for its next transformation. This refined powder will soon become a crucial component in the production of foam glass, showcasing the incredible potential of recycled materials. Now, it's time to create the perfect mix. The glass powder is combined with a tiny amount of carbon-based foaming agent, less than 1% by weight. This blend is mixed thoroughly so every glass particle is close to carbon. Uniform mixing is crucial. Uneven distribution means weak, useless foam. Sometimes, a bit of water is added to help the powder stick together, then it's rolled into a thin sheet. This sheet ensures even feeding into the furnace and controls the final product's thickness. The mix is now ready for its fiery transformation. The magic ingredient is set to bring the glass to life. The mix sheet enters a massive tunnel furnace, heated to around 900–1000 degrees C. The glass softens, and the carbon foaming agent releases gas, forming millions of tiny bubbles. The slab swells, expanding to many times its original size, like a giant cake rising. Temperature and speed are precisely controlled, too hot or too cold, and the foam collapses. After 45–60 minutes, the slab emerges as a thick, rigid black foam, still glowing hot. Its density is so low it can float on water. The transformation is complete, from powder to lightweight super-insulating foam. The structure is now filled with sealed air cells, giving foam glass its unique properties. What started as waste is now a high-performance material. The glass has been reborn. It's ready for the next step. The hot foam glass slab cools slowly in a process called annealing, building up internal stresses. Instead of cutting, the slab is moved onto a vibrating breakout table. The vibration triggers the slab to fracture cleanly along engineered lines. No saws needed. This preserves the closed cell structure, keeping the blocks waterproof and insulating right to the edge. The blocks are sorted by size and quality. Offcuts and irregular pieces aren't wasted. They're sent back to be ground up and reused. Nearly 100% of the material is recycled within the process. The result, consistent, high-quality foam glass blocks. Nothing goes to waste. Finished foam glass blocks are stacked sealed in tough polyethylene bags and labeled with batch and technical info. Automated systems stack the bags onto pallets, which are tightly wrapped for stability. Pallets are stored in the warehouse, ready for shipping worldwide. Trucks, trains, and ships deliver foam glass to construction sites and distributors. Each pallet represents glass saved from landfill and transformed into something valuable. The journey from trash to high-tech insulation is complete. It's a process that's both sustainable and efficient. A job well done. Where does all this foam glass go? Its unique properties make it a construction superstar. It's used as insulation under building foundations, especially in cold climates, creating a thermal break and saving energy. Foam glass supports green roofs, flat roofs, and heavy loads while staying waterproof and rot-proof. It insulates exterior walls and basement floors, resists mold, and keeps buildings healthy. In industry, it insulates pipelines carrying supercold liquids and storage tanks for chemicals and gas. Its fireproof, inert nature adds safety and reliability. Civil engineers use foam glass aggregate as lightweight fill for roads, bridges, and retaining walls. It prevents settling and reduces load on weak ground. From homes to highways, foam glass quietly makes our world safer and more efficient. It's the hidden hero of modern construction. The story of foam glass is about more than recycling. It's about smart, sustainable innovation. Every block represents glass that didn't end up in a landfill, saving space and resources. The process is nearly zero waste, with offcuts recycled back into production. Foam glass dramatically reduces building energy use, shrinking carbon footprints for decades. Its durability means it keeps working for generations. This is circular economy in action, turning yesterday's trash into tomorrow's infrastructure. With a little ingenuity, we transform problems into solutions. Next time you see a glass bottle, imagine its potential as insulation, as a roadbed, as part of a cleaner future. That's the magic of foam glass, turning waste into a foundation for a better world.